Okay, so we're back with section 1.2 talking about fractions. So first we need a fraction to talk about. And I'm going to pick a not really common fraction, but relatively basic fraction. So this fraction, or every fraction actually, has three different parts to it. It has the top number, the bottom number, and then that little line in the middle there. So first off, let's talk about the top number, that value 5. What is that? That's actually called the numerator. The value on the top of a fraction is always called the numerator, and then the bottom is called the denominator. Now, the last part to a fraction is that little line in the middle, and nobody really ever knows what it's called. It's actually called a fraction bar. Now, the fraction bar implies division. You're really saying 5 divided by 6, or you could say 5 over 6, or 5/6. That's another way to word it as well. The first thing that I keep on forgetting to cover these up, giving you a sneak peek of what's to come. The first thing that we have is we have this thing called lowest terms. Lowest terms of a fraction. A lot of times when you're asked to talk about a fraction, you're saying, oh, give me the answer in a fraction in lowest terms. Well, lowest terms of a fraction is just when the numerator and the denominator, it says, have no factors in common. Now, factors we learned from the previous class. Factors are just numbers that multiply together to make that value. So again, when the numerator and the denominator have no factors in common. For instance, we could use the value, let's say 1/2. The value 1/2 is in lowest terms. However, an equivalent fraction is 2/4. Right? They mean the same thing, but 1/2 is in simplest terms, lowest terms, and then 2/4 we can divide by the common factor of 2. So along with that comes something called your greatest common factor, and that's the easiest way to simplify a fraction, is to find the greatest common factor. The greatest common factor is the largest factor that's common to 2 or more numbers. Now obviously, since we're talking about a fraction, it can only be 2 numbers. So for instance, if we look back at our example up here, 2 and 4, the greatest common factor, or GCF, of 2 and 4 is 2, because we can divide both 2 and 4 evenly by 2. Now when we are writing something in lowest terms, we want to simplify it, and that's using our basic principle of fractions. Our basic principle of fractions basically says if you have a value, if you have a fraction that can be written as a times c over b times c, what you're actually able to do is you're sort of able to split it up here. I'm going to show you the long way what you're really doing. You're really taking a over b times c over c. Right? C over c, a lot of people say, oh, it cancels out. It does cancel out, but really a value over itself is really 1. Later on, we're going to learn that this is called your multiplicative identity. Anything times 1 is just itself. So that's sort of the long way of going about it. Really, once you're able to divide it by a value, you can just say, okay, well, that just equals a over b. So now the first step to simplifying fractions is to find the greatest common factor. So we want to find the greatest common factor for each pair of numbers. Now there's a bunch of different ways to do it. One way is to just list all of the factor pairs. I like prime factorization, and that's something we just learned, so it's good practice. So I'm going to go ahead and prime factorize both of our numbers. So we have 8, which we can break up into 2 times 4, and further break up into 2 times 2. And then we have, 8 is 2 times 2 times 2. And then we have 12. We can break that up into 2 times 6, and that can further break up into 2 times 3. So 12 is 2 times 2 times 3. And basically what we're going to do to find the greatest common factor is we're going to find what factors do they have in common. Well, they have that 2 in common, and they have that 2 in common. Now, it doesn't necessarily have to be in the same position. Right? You could say that 2 is common with that 2, but it really doesn't matter. So basically, we have 2 and 2, so 2 times 2 is 4. So that means our GCF is 4. Right? The 2 common factors multiplied together. And we just can double check that. Is 8 divisible by 4? Yes, it is. 8 divided by 4 is 2. And then 12 divided by 4 is 3. So we have it down to its simplest form. Next, we're going to do the same thing for 495 and 735. So we're going to need a little more room. I hope I have enough room here. Otherwise, I'll just extend a little. We'll see what we have. Okay, so 495. I can see that that is divisible by 5. Whoops, I got rid of my calculator. 495 divided by 5 gives us 99. I can see that 99 is divisible by 11. 11 and 9, and then we have 9, which is 3 and 3. Next, 735. Oh, whoops, let's write it down here. 495 equals 3 times 3 times 5 times 11. Okay, so 735, excuse me, we can also divide that by 5. 735 divided by 5, that gives us 147, which is divisible by 7. It's 21. It's divisible by 3 and 7. So 735, 3 times 5 times 7 times 7. So now we look, what do they have in common? Well, they have a 3 in common and they have a 5 in common. So that means the GCF is 3 times 5, which gives us a value of 15. So now we're going to use all of this information to actually simplify these fractions, right? 8 over 12, we knew that the GCF from that previous problem was 4, so we can rewrite it as 2 times 4 over 3 times 4. Again, the 4's sort of cancel out, and we're just left with 2/3, and that's completely simplified. Then we go ahead and look back at 495 and 735. Now if we look at the factors that we have here, I have it on this piece of paper. Let's see if I can do this nicely. So if we look at 495, we have a 3 and a 5 that were in common. So that's part of the 15. Well, you could either take your calculator and do 495 divided by 15 and find the answer, or you can look at the other factors, right? The other factors left over are 3 and 11. So you can multiply that together. 3 and 11 gives you 33. So 15 times 33 equals 495. Then we have 735. Again, the 3 and the 5 are part of the GCF of 15. And then we have 7 times 7, which is 49. Our 15s cancel out per se, and we're left with 33 over 49 as a fraction in simplest terms or lowest terms. So now that we've talked about simplifying fractions, we want to go ahead and learn how to do operations on fractions. Operations, multiplying fractions, dividing fractions, adding fractions, and then subtracting fractions. So first, multiplying. Oops. When we're multiplying two fractions together, we'll say very general, A over B times C over D. We simply multiply straight across. The numerator times the numerator, and then the denominator times the denominator. So whatever this is, AC over BD. Let's practice. We're going to multiply these fractions together. Now, one option is to multiply it together and then simplify from here. Or you can also do something called cross-simplify or cross-reduce. How much space do I have here? So I'm going to show you both options for this. We'll see how that works. So for our first one, we have 4 over 5 times 6 over 7. If I look at each fraction individually, first we can check those. Can we reduce either fraction, or are they completely simplified? Here, 4/5 is completely simplified, and 6/7 is also completely simplified, so that's done. Then we can look at one of the numerators over the other denominator, so 4 over 7. If we wrote that as a fraction by itself, would that be simplified? 4 over 7, yes. And then also 6 over 5, yes, that would be simplified. Now, by doing that simple check, when we multiply it all together, like we have up here, we're actually going to have a value, an answer, a product that's completely simplified already, which makes it really nice. We're dealing with smaller numbers here, smaller numbers at the end. So, multiply straight across, 4 times 6 over 5 times 7. And of course, we can't just leave it like that. We want to multiply it together. 4 times 6 is 24. 5 times 7 is 35. And it never hurts to double check. Can we divide? Do they have any common factors? Let's see. 3, no. 4, no. 6, no. Not 7. 8, no. Not 9, not 10, not 11. 12, no. Okay, so there we go. 24 over 35. Now what about this? We don't have a fraction times a fraction. We have a whole number, 3 times a fraction. Well, how can we make it into a fraction times a fraction? Any whole number we can simply write as 3 over 1 times 5 over 9. So again, we go ahead and check, is everything simplified? 3 over 1, yeah, that's simplified. 5 over 9 is simplified. 3 over 9, is that simplified? No, it's